All right, so let's just jump right in. Everybody's talking about AI, right? How to deploy it, what it can do. But we're going to tackle the one question that, honestly, almost everyone overlooks. Is your network actually ready for it? Let's figure that out.
When we talk about the cost of AI, our minds immediately go to the big stuff, right? The fancy GPUs, hiring brilliant data scientists, but there's this hidden cost, a network tax, if you will, that comes along with all this amazing innovation. And trust me, it can be a surprisingly heavy one.
I mean, there's no doubt about it. AI is a total game changer. It's completely reshaping industries, creating opportunities we couldn't have even dreamed of. And of course, every organization is rushing to get in on it, looking for that competitive edge. But here's the thing. What happens when you take this brand new high performance engine and you try to run it on roads that were paved, decades ago? And the sheer scale of the impact here, it's just staggering. We're talking about a potential network load increase of up to 35%. Just think about that for a second. That is not a small jump. It's a massive, fundamental shift in how your entire infrastructure is being used. And that brings us to the absolute heart of the matter, the central question of this whole explainer. It's not just about, hey, does our shiny new AI work? It's about, does our AI work without completely breaking everything else? All those human critical services your employees and your customers depend on every single day. So to really get a handle on this risk, we've got to talk about a concept called network debt. And what's interesting is this isn't about new problems that AI is creating from scratch. Nope. It's about the old, hidden problems it suddenly brings to light. Because AI traffic, well, it's nothing like human traffic. It's way different and, honestly, a lot more dangerous.
I mean, just think about it for a second. Most of our corporate networks, they were built for people, for us. We click a mouse, we type an email, we download a file every now and then. Our interactions are, relatively speaking, pretty slow, one after the other, and kind of predictable. The whole network was designed around that rhythm, that human scale.
But AI traffic? Oh, it's a completely different beast. It's machine scale. That means it's incredibly fast. It's all happening at once, and it is relentless. It never sleeps. It doesn't take coffee breaks. This intense, brand new demand acts like the ultimate stress test on your network, and it finds everything, all the little shortcuts, the quick fixes, the weaknesses that have been lurking under the surface for years. That is your network debt.
So, what does this network debt actually look like when it shows up? Well, it shows up as failures. And these aren't small hiccups, they are incredibly costly failures. A little bit of latency? That's not just an annoying lag anymore. It means the AI's answer, its whole reason for being, arrives too late to even be useful. A bit of packet loss? It's not just a slow download. It can literally corrupt the very data your expensive model is training on, wasting huge amounts of time and money. Okay, so if this massive risk is just hiding there in our infrastructure, how on earth do we find it before it finds us? Right? That's the million-dollar question. And this is where we pivot from talking about the problem to talking about the solution. We need a totally new way to measure this new kind of risk.
And that's the fundamental challenge, isn't it? How do you measure something you can't even see? A risk that's buried deep inside the tangled web of your network. Well, you need a new lens, a new way of looking at it. And that new lens has a name, the Infrastructure Stress Score, or IS for short. It's a single number, something you can actually measure, and it's designed to do one thing: quantify the unique pressure AI is putting on your network. Basically, it makes the invisible visible.
Whoa, okay. I see you. You're looking at this formula and it might seem a little intense, but don't worry. Put the calculator away. We are not going to do any math here. The really important thing is just to understand the pieces of the puzzle. What actually goes into calculating this risk score? So let's break it down. It really boils down to four key things. First up is bandwidth. Pretty straightforward. How much of your traffic is actually from AI? Is it just a trickle or is it a fire hose? Second, latency and concurrency. This is about how needy the traffic is. How sensitive is it to delays? Does it all need to arrive at the exact same time? Then you've got the agent type. A simple AI doing one thing is way different from a whole swarm of autonomous AIs working together. And finally, your IP address space. Are you still running on the old, cramped IPv4 system, or have you moved to the much more scalable IPv6? Each one of these things can seriously multiply your risk.
Okay, so having a technical score like IS, that's fantastic for the engineers. But at the end of the day, to everyone else, it's just a number. To make it really mean something, to make it useful for the business, you've got to translate it. You have to connect that technical score directly to real-world business risk. And that's exactly where this next formula comes in, the probability of an unexplained outage, or PUO. What it does is brilliant. It takes that technical IS score and turns it into the answer to the one question that keeps every tech leader up at night. What are the chances we're going to have a massive outage that I have to go explain to the leadership team? And this chart, this lays it all out, plain and simple. If your IS score is under zero point 0.5, hey, you're looking good. You've got safe margins. If you're somewhere between 0.5 and 2.0, well, you're in the yellow zone. You're starting to feel the strain, and it is definitely time to start optimizing. But if that score creeps over 2.0, that's not a warning light anymore. That's the alarm bell. The model is basically screaming that something will break. It's just a matter of when. All right, so we've diagnosed the problem, we've figured out how to measure the risk. Now for the most important part, right? What do we actually do about it? Let's walk through a super clear 4-step plan to get you from diagnosis to action. Okay, step 1, baseline your reality. You have to know what your network looks like right now. Utilization, latency, the works. You can't map out a journey if you don't know your starting point. Step 2, profile your AI workloads. Remember, not all AI traffic is created equal. You got to know what you're dealing with. Step 3, now you calculate. Use those formulas we talked about to get your actual IS and PUO scores. And finally, the crucial step 4, produce that readiness report. Turn all this data into a story that leadership can actually understand and act on. You know, when you boil it all down, it comes back to one simple truth. And this quote from the source material just says it all perfectly. AI fails not because the AI itself is bad, but because our networks simply were not designed for this kind of machine-scale intelligence. The absolute key, the most important takeaway, is to measure that gap. The gap between what your network was built for and what AI demands of it before a massive failure exposes it for you. And that brings us full circle, right back to the question we started with. But the difference is, now you have the framework to actually answer it. So I'll leave you with this one thought to take back with you. Is your network really ready for what's coming?